Good evening, everyone. My name is Krish Bhardwaj. I am a second year student from Charuta University of Science and Technology, and today I am going to explain you about interrupts in the computer system. So, let us begin. So the first question arises that what is the meaning of interrupt? So an interrupt is a signal that tells the CPU to stop the current execution of the task and execute ISR, that is interrupt service routine. It is a special code that is used to return to handle the interrupts that had occurred in the devices or in the programs. So now let us look at the whole picture of the interrupt cycle. So what happens is that whenever an interrupt has occurred in the device or in the program, it sends an interrupt request to the CPU via a special line called as interrupt line. Now the CPU will does not stop immediately. It will stop in the middle. It will first complete the current execution of the instruction, then save the current state with the help of the different registers and one special register called as program counter, which is used to store the address of the next instruction that is going to execute. Now the CPU needs to find out in which device it has sent the interrupt. For it is uses a special number called as interrupt vector number, which is used to find the address of the ISR. Obviously, there are different types of the interrupts, such as hardware interrupt, software interrupt, and there are various classifications on the hardware as well as software. Therefore, the unique number, that is interrupt vector number, help us to find the correct ISR code which is used to deal with the interrupts. Now the CPU will execute a special program such as interrupt service routine to handle the interrupts generated. And finally, after covering the whole part of the ISR and executing the task and the instructions listed in the ISR program, we'll finally recover our instruction that is previously we are going to execute. So now let us see a small animation of the whole process that I have discussed here. So first of all, we will understand what are the things in the here. So here we can see that there is a stack memory, there is a register, there is a program counter, as it is used to store the address of the next instruction that is going to execute. Here I have taken a hardware interrupt in which specifically keyboard is giving the key in which keyboard has occurred an interrupt. There is a disk drive, there is a PIC is a very important device. It tells us which interrupt we have to occur or which interrupt we have to execute first based on the basis of the prioritization of the different interrupts. Here is a disk drive, here is a IVT. IVT also plays a very crucial role. IVT stands for the interrupt vector table, which help us to map the correct ISR that is we are going to execute to handle the interrupt. So now here we have the different steps. Here that is 1 to 7 step we are going to follow to complete the whole interrupt cycle. So the first step says that IRQ signal send, that is interrupt request, finish current instruction, save CPU state with the help of all these things, identify the interrupt, that is IVT, jump to the ISR, handle interrupt, and IRET. IRET stands for the interrupt return. Obviously, we have to, after completing the interrupt, we have to after completing the interrupt, we have to move to the current execution of task that the CPU has stopped previously to handle the interrupt. And here are the descriptions about CPU, PIC, PC, register, stack, IBT, as well as ISR. So let us move to the animation. We will see the animation and we'll try to understand what the interrupt in the computer system means. So I will just click on the play button. Okay, so it's telling me that it's executing first step, that is IRQ signal sent. So the keyboard and the disk drive has sent to the PIC, PIC sent to the CPU. Now CPU is executing current task and it is trying to complete the current task. Now the CPU is storing the state of the task. Here we can see that the finish current instruction and it is saving the CPU state. Okay, so now it is trying to find out the correct ISR with the help of the IVT table. So now it moves to the IVT table. IVT table will send to the ISR, that is what type of ISR we are going to execute. And ISR table, jump to the ISR table, and ISR table sent to the CPU, that is the correct code which we have to execute to handle the interrupt. And after that, we will send to the IRET, that is interrupt return, that is all the process complete, and CPU please move to the instruction that you are going to execute. So here I just increase the speed and please take a have a look. So finish instruction, this happened, CPU state. Obviously, now we have to identify the interrupt from the IVT table and ISR, then jump to the ISR, then handle the interrupt as well as IRET, that is interrupt return. So this all from the my side. Have a nice day. Thank you.